Hello there, welcome to African Hope Learning Center online sessions. It's me, Elijah, and today we shall be talking about the simultaneous equations, and we will basically be talking about how we can solve simultaneous equation algebraically. As we had looked in the previous lessons, how to solve simultaneous equations graphically. So we are going to see how we can use the algebraic techniques to solve simultaneous equation in these sections. To solve simultaneous equation algebraically, there are two methods that we shall be looking at, two ways to do that. One of them is called elimination methods, but in Sudanese book they call it cancelling by additions. Then second one is called substitution methods, and this substitution method is divided into two sections. One is called cancelling by equivalence, and then secondly is called cancelling or solving by substitutions. So we are going to focus in this video on elimination methods, which is cancelling by additions. So this method is based on the idea that the two numbers with the same values and different sign cancel out. For example, if you have -2 and +2, if you add them together, they will cancel out. So this is the background knowledge that you guys should be familiar with. The reason for cancelling out is to simply remain with one unknown, as you cannot possibly solve equation with two unknown without knowing value of one unknown. So we actually have to eliminate one variable so that we remain with one unknown, and then it will be very easy for us to solve one unknown. So we reduce these two equations into one equation with one unknown, and then if we get the value of that unknown, then we will substitute it into an equations, and then we will get the value of the second unknown. So we cancel out one unknown and we remain with one unknown we can solve. So what are the steps of elimination methods? Or cancelling. So the step of elimination methods, which is cancelling by equivalent, is based on two steps. One is to multiply both sides by two numbers, and these two numbers are going to be the coefficients of the variable that you want to eliminate in both sides. For example, in equation 1, if we have coefficient as 3 and equation 2 coefficient as 4, then we will take the coefficient 4 in equation 2 and we multiply it with equation 1. Then we take 3, which is in equations 1, and then we come and multiply it with equation 2. So that is what we actually do. And then if we do that, we will have to make sure that we have two values, two numbers of the coefficient of the same values but different signs. So if they are not having different signs, then you are going to subtract instead of adding. So number 2, we are going to add two equations to get one equation with one unknown. So if the two unknowns are equals and they have the same signs, then we have the subtractions. So here we shall be looking at the examples of simultaneous equations. So this is one of the examples of the simultaneous equations that I have taken in the Sudanese book. And here equation 1 is x plus y is equal to 10, and then equation 2 is x minus y is equal to 4. Okay, as you can see, this these are two equations with two unknown. X is not known, y is not known. So our target here is to find the value of x and y. So we are going to add the two equations because the coefficients of y, okay, as you can see, the coefficient of y here is 1. It's not actually written, but it is there, it is 1. Then the coefficients of y also here is negative. So now these are the two values with the same magnitude but different signs. So this is negative and this is positive. So they are inverse of each other. This is what is meant by inverse. So if one is negative and one is positive and you add them, so they cancel out, okay? They cancel out here. So we are just going to add them. We are not going to multiply, as I said before, because the coefficient is 1. So there's nothing that you can do. If the coefficient is already, or the coefficients are already the same and they have inverse. They are inverse of each other, okay? So we are going to go straight away to additions. So there is no multiplications here because the coefficients are the same. So what do we actually do? We add the two equations. So how do we do the additions? We add x with x. So x plus x plus this plus, okay? Y plus negative y. So we have y plus negative y, okay, is equal to 10 plus 4, okay? So the result here, x plus x is equal to 2x. Y plus negative y, as you can see, this is like y minus y, because negative and positive give you negative. So you have 0 here. Y minus y is equal to 0. That's why we will have 2x here. It's equal to 14. Okay? Because this is 10 plus 4. Now you have seen you have reduced these two equations into only one equation with one unknown. Our unknown here now is x. So the next target left with us is to find the value of x. So let us say these equations 2x is equal to 14. We assign it to be equation 4. So we now have one equation with one unknowns. So we are going to find the value of that unknown. So this 2x is equal to 14 is now our equations 2. Okay. So now we can easily solve the value for x. We can solve the value of x here. So to solve x, we divide both sides of the equation by 2. As you can see here, 2 is the coefficient of x. So for us to remain with x here, we divide both sides by 2, both sides by 2. Okay? As you might have guessed, if you divided 2 and 2, then you remain with 1. If you divided 14 and 2, then you remain with 7. So we have one x here, but we don't actually write 1. So we have x is equal to 7. Now that we have gotten the value of x, what are we going to do next? So now we have the value of x. So we can easily find the value of y by substituting x, this value of x, into any equations. So let's take one equations. Okay. So we are going to take equation 2, and equation 2 was x minus y is equal to 4. So if you take x is equal to 7 and put it in place of x, so you take 7 here, then you will have 7 minus y. So if we put 7 in place of x from the equations, we have a new equation which is going to be 7 minus y is equal to 4. So what do we do in order to remove 7 here? We have to subtract both 7 from both sides of the equation. So if we say 7 minus 7, this minus here wasn't for 7, it was for y, so it remains as minus y. It's equal to 4 minus 7. As you can see, if you subtract 7 here and 7 here, if you subtract 7 here, then you remain with 0. So 7 minus 7 is equal to 0. So if we are going to have 0 minus y is equal to 4 minus 7 is equal to negative 3. So basically we are going to have negative y here is equal to negative 3, but negative is common on both sides, so we are going to divide both sides by negative 1. So if you say negative y all over negative 1, then negative and negative cancel, so you remain with y. Negative 3 divided by negative 1, negative and negative cancel, and then you remain with 3. So our final answer is y is equal to 3. That is basically how you solve simultaneous equations algebraically using elimination methods. So we are going to look at another example here. So let's analyze this equation, these questions now. In these questions, as you can see, there are no coefficients here that are the same and of opposite value or opposite sign or of inverse sign. So what are we going to do then? So in these questions, we have realized that there is no any variable with inverse coefficients. So we are going to choose the variable we want to eliminate and check its coefficient. So which one do we want to eliminate here, y or x? Before we took y, so let's stick to this one here. So let us take y. So if we take y, then the coefficients of y in the first equation is 4. Then the coefficient of y in the second equation is negative 3. So here, since we have decided to eliminate, we are going to follow these steps, okay? First step, you multiply equations 1 by coefficient of y in the second equation. So we multiply equations 1 by coefficient of y in the second equation. So the coefficient of y for this matter is negative 3. Actually, it's supposed to be negative 3. Here I made a mistake. So this is supposed to be negative 3. And then the coefficient of y in the first equation is 4. The coefficient of y here, this is what I mean. Coefficient of y here is 4. So we are going to put this 4 here, okay? Now, we are going to multiply negative 3 with 3. So negative 3 times 3 give us negative 9x. Negative 3 times 4 give us negative 12. Negative 3 times 1 give us negative 3. It is actually negative here. I made a mistake. I should have written negative here, okay? So that's why you have negative here and negative here. So what is the second equation? The second equation will become 4 times 2 will give us 8. 4 times 3 will give us negative minus 12. And then 4 times 12 will give us 48. So we have now multiplied. So what is the next things? The next things that we are going to do here is to actually do the addition. But unfortunately, the values of coefficients in equations 1 and coefficient in equations 2 are not opposite. Actually, they are equal, but they also have the same sign. So in order to solve this problem, instead of us to add, because if we add this negative 12 and negative 12, we are going to get negative 24, which is not what we want. We want this one to cancel out. So in order for this to cancel out, we have to introduce what? We have to minus, we have to subtract them. So when we subtract negative x minus 8x, okay, we get negative 17x. So when we subtract negative 12 minus negative 12 minus 12, which is going to give us negative, and negative here give us what? Give us positive. So we have now negative 12 plus 12 is equal to negative 3 minus 48. So if you have negative here and negative here, you just add the numbers and then you retain the sign, which is subtraction. So here we are going to have negative 17x minus 12 plus 12. So this minus 12 plus 12 is just like 12 minus 12. So we are going to have 0 here. So here what remains with us on this side of the equation is negative 17x is equal to negative 51. Okay, as you can see, we need to remain with only x here. So what are we going to do for that? What we are going to do is that we now have this single equation with single unknown. So we are going to divide both sides by negative 17, both sides by negative 17. Negative 17 by negative 17 give us 1. So we are only going to remain with x on this side. Negative 51 and negative 17, actually negative and negative cancel, but 51 divided by 17 is equal to 3. Okay, because if you say 3 times 7 is equal to 21, and then 3 times 1 is equal to 3 plus 2, which is 51. So it is 3 here. So that implies that x is equal to 3. Okay, now if we find the value of x to be equal to 3, how do we find the value of y? We take any of the equations from the two equations. So here we are going to take equations 2, and equations 2 is 2x minus 3y, which is equal to 12. Okay, so here therefore we are going to take the value of x before, which was 3, then we substitute it in place of what? In place of x. So we are going to have 2 times 3 plus 3y. Another mistake here. It's supposed to be minus 3y is equal to 12. Okay, so here we are going to have 6 minus 6, which gives us 0, and here we have negative 3y. So this positive is not supposed to be positive, it's supposed to be negative. So here we are going to have like 3y, negative 3y is equal to 12 minus 6. So we are going to have 3y is equal to 6. So we divided both sides by 3. Actually, it's not supposed to be just 3 here, it should be negative 3. So if we divide both sides by 3 and 3, and then we get 2. Actually, the real value here is going to be negative 2 because I have forgotten the negative here. So just add that. So the solutions of simultaneous equation is going to be y is equal to, I said before, this is negative 2. So it's going to be y is equal to negative 2 and x is equal to 3. And then now we have solved simultaneous equation using elimination methods. Okay, so please watch the video and tell me if there is anything difficult. Just let me know. Thank you.